Okay, this is going to be the first lesson in Unit 4. We're going to start with this concept of long division because you're going to need this, all right, when we go to do asymptotes in a little bit. So a little bit different than synthetic division. What you want to do, this is like old school long division from when you were younger. Okay, same thing like synthetic. All right, make sure it's got an x cubed, an x squared, an x term, and a number. Okay, and I'm going to leave some space in here, and I'm going to explain why in a second. All right, plus 5x minus 7. Okay, so the idea here is we want to figure out what times x squared would give me 2x cubed. Well, that would just be 2x. So 2x times that would give me 2x cubed. I take 2x times this, I get negative 8x. Okay, now I got to be careful here because that would go underneath this term. Okay, 2x times that would give me that. Now, what I'm going to do is I'm going to subtract. Okay, so 2 minus 2, this goes away. Okay, 5. Now, what you have to do when you have a minus and negative, that turns into a plus. So that would be 13x. Okay, and then everything else comes down. Negative 4x squared. Okay. Move this over just a little bit. Negative 4x squared, positive 13 minus 7. Okay? So then I want what term times 4x squared would give me this. Okay, that's just going to be negative 4. Negative 4 times that would be negative 4x squared. Negative 4 times negative 4 would be positive 16. Okay, you just got to stay organized with your columns. Okay? All right? This would basically cancel out. All right, I'm subtracting here. Negative 7 minus that would be negative 23, and then this comes down. All right, now, if you notice, what times x squared would give me this? It would be nothing. So this right here is your remainder. Okay, and just like last time, what we would write is 13x minus 23 over x squared minus 4. Okay, what I divided by. Okay, so that's long division. Let's do another one. Okay. All right, so I got x cubed minus 5x squared minus 2x plus 7 divided by x squared plus 3x minus 1. Okay, what times x squared would give me x cubed? That would just be x. So that would be x cubed. X times this would be positive 3x squared. X times negative 1 would give me negative 1x. Once again, I am doing subtraction. So this basically goes away. Negative 5 minus 3, okay, would be negative 8x squared. Negative 2 minus negative 1, those basically become positive. All right, so that'd be minus 1x with a plus 7. Okay? Then once again, what times x squared would give me negative x squared? Okay? And that's just going to be negative 8. Times that would be negative 8x squared. Negative 8 times 3 would be negative 24x. Negative 8 times negative 1 would be positive 8. Make sure you put your subtraction signs in there. Okay? So that's going to go away. Negative 1 minus negative 2, that becomes a positive. That would be 1x. 7 minus 8 would be negative 15. Okay, let's check. Nope, I cannot go any further, so this would be my remainder. Okay, in this case, I divided by x squared plus 3x minus 1. Okay? All right, so what I'd like you guys to do, okay, is go ahead and pause your video, okay, and use long division. Okay, go ahead and unpause. Okay, so I got 3x cubed minus 6x squared plus 4x minus 9, x squared minus 4x plus 5. Okay? So what times x squared would give me 3x cubed? That's just going to be 3x, okay? So I got 3x cubed. 3x times that would be negative 12x squared. 3x times 5 would be 15x, okay? Minus, minus, minus. Okay, this goes away. Negative and negative becomes positive, so that would be 6x squared. 4 minus 15 would be negative 11x, and bring down that would be negative 9. Okay? Then what times x squared would give me 6x squared? Pretty simple, that's going to be 6. 6 times that would give me negative 24. 6 times that would give me 30. Okay, minus, minus, minus. This goes away. All right, that's a double, that turns into a plus, so that'd be 13x. 9 minus that would be negative 39. So this is my remainder. 13x minus 39 all over x squared minus 4x plus 5. Okay? All right, so that skill of long division, we're going to use it a little bit. Okay? Now, what I want to talk about, this unit is on rationals. Okay? All right? And we have both vertical asymptotes and horizontal asymptotes that we have to find. Okay? And I want to go through some different examples here for you. All right? So we talked about this graph before, all right, where we had the anchor point was at 3, 5, okay? All right, and we drew it out, okay? Now the idea behind the vertical asymptote is it is an x equals, okay? The horizontal asymptote is a y equals, okay? So pretty easy here. With my anchor point, this would just be 3, and this would just be 5. It's that simple, okay? All right, it's that simple. Now, here's a second scenario. When you have the same letter, okay, the same power, so it's the same power over the same power. Let me explain it what you do. All right, the vertical asymptote, okay, the vertical asymptote comes from solving the denominator here. So this would end up being x equals 3 halves. All right. The horizontal asymptote is a y equals equation, and it comes from dividing the two numbers here that are in front. So 8 divided by 2 would give me 4, okay? All right, and what we're talking about with vertical asymptotes are these dashed lines. Horizontal asymptotes go like that, okay? Now, with the scenario where the bigger power is in the denominator, okay? That's a different scenario, okay? The vertical asymptote is found the exact same way, okay? It is solving the denominator, so that would be x equals 4, all right? So basically, we solve the denominator, we solve the denominator, okay? All right? For the horizontal asymptote, when you have this scenario, it would just be y equals 0, okay? Now, the next one is where the bigger power ends up being in the numerator. For this one, it is going to be a slant asymptote. We'll talk about that, all right? We'll talk about that in a little bit. So all I want you to be able to do for right now is if you get the bigger power, to identify it as a slant asymptote, okay? So what I would like you to do, okay, is go ahead and pause your video and see if you can figure out the vertical asymptote and the horizontal asymptote, okay? All right, go ahead and unpause. All right, so my vertical asymptote right here is I would solve the denominator, so that would end up being x equals negative 2/3, okay? Now, this is a scenario where I have the same power. So what I do is I divide those. 8 divided by 3 would just be y equals 2. Okay? This one's one of those ones we've done from the past. The anchor point is negative 7, negative 4. That means my vertical would be x equals negative 7. My horizontal would be y equals negative 4. Okay? What scenario do we have here? The bigger power is in the top. So this will be a slant asymptote. And we'll do other examples of that in a little bit, okay? This one, the bigger power is down here, okay? So what I would do to get the vertical is I would solve the denominator, that's x equals 9, all right? And it's just gonna be that special one of y equals 0, okay? All right? Now, let's move on to the next thing that I would like to do for today, finding the domain. We sort of have done this in the last few units, okay? All right? Finding the domain, what that means is we have to find basically what the infinite discontinuity which in this chapter is your vertical asymptote, okay? We want to find also the removable discontinuity, which we will call your hole, okay? All right? So, what you have to be able to do is to be able to look at these questions, okay? And what you're going to want to do is you're going to want to factor if possible, okay? You're going to want to factor if possible, all right? So how would I find the vertical asymptote here? Okay, well that's just going to be the anchor point would be -2, -7. So my vertical asymptote would be x equals -2. Okay, so what's my domain? My domain, okay, if you want to use interval notation, -infinity to -2, union -2 to infinity. Okay, if you want to use set builder, x is an element of all real numbers, such that x can't equal -2. Okay, all right, so either way is fine. All right, what's this example? We just learned that one. This is going to be my vertical asymptote. Is going to be x equals 9. So once again, I could go -infinity to 9, union 9 to infinity. Or I could do x is an element of all real numbers, such that x can't be 9. Okay? Now, I'm going to have to factor this one. Okay? All right, so if I factor this, this would be x plus 6, I think, and x minus 4. This will be x minus 4 and x plus 1. Now, we've learned this from the previous units that these two things eliminate, okay? So what I got here is up top is x plus 6 over x plus 1, okay? So this was removable, okay? That's going to be called a hole, and we're going to get into the next class. We'll talk about how to make graphs for this stuff, but for right now, we just want to learn some of the concepts. This would be my infinite discontinuity at x equals -1. Okay, so I basically have a vertical asymptote at x equals -1, okay, and I have a hole at x equals 4, okay? So what would my domain be? Set builder might be the easier one. X is an element of all real numbers, such that x can't be -1 and x can't be 4, okay? If you do the interval notation, you have to sort of build up, okay, so it'd be -infinity, all right, to -1, union -1 to 4, union 4 to infinity. So you have to treat it almost like a number line if you think of it this way, negative, all right? So you can't use these two, so you'd have to build it like that. That's one way of doing it, okay? Let's look at this one, all right? What's going to happen here? This is going to eliminate, and this is going to eliminate. So what ends up happening is that's going to be x minus 9 over x minus 5, and then the bottom is x minus 2. Okay? This is actually going to be a slant asymptote, which once again we'll talk about, all right, in the next classes, all right? But what I got is I got a hole at x equals 8, and I got a vertical asymptote at x equals 2. So an infinite and a removable, okay? So once again, that would be all real numbers, such that x can't be 8, okay, and x can't be 2, all right? Set builder, you're going to have to look at a number line. I'd have 2 and 8, okay? They can't have those two, so that would be -infinity to 2, union 2 to 8, union 8 to infinity, all right? You can use either one to come up with your answer, okay? So what I'd like you guys to do, okay, is go ahead and pause your video as soon as my okay, and what I like you to do, pause your video and go ahead and work on these, okay? All right, go ahead and unpause your video, all right? So I would have to factor this. We talked about factoring cubes before, okay, in our previous unit, which you guys did a pretty good job with. That's minus cube root, that's going to be x and 2. This times this has got to give me that, which would be x squared. -4 times 4 would give me -8. All right, remember we multiply that, gives me -2x, change the sign, okay? This bottom part is just going to be x plus 2, x minus 2. Okay, so what's going to happen here? These two would go away. I would have a hole at x equals 2, I'm going to have a vertical asymptote at x equals -2, okay? So what's my domain? If I do set builder, x is all real numbers such that x can't be 2, x can't be -2, okay? Once again, if I'm doing a number line, if I want to do interval notation, it would be -infinity to -2, union -2 to 2, union 2 to infinity, okay? You can use either one, all right? Here, I just am going to have a vertical asymptote at x equals -5, all right? So x is an element of all real numbers such that x can't be -5, all right? Interval notation will be -infinity to -5, union -5 to infinity, okay? All right, this one's already been factored for us, all right? That eliminates, so I would have an x equals 7 would be my whole, all right? And x equals 2 would be my vertical asymptote because I would be ending up with this, okay? All right, so x is an element of all real numbers such that x can't be 7, x can't be 2, okay? Or if you wanted interval notation, okay, that number line would be 2 and 7, so -infinity to 2, union 2 to 7, union 7 to infinity, okay? This one, very simply, has an anchor point of this, so my vertical asymptote would be x equals -10, okay? So it's all real numbers such that x can't be -10, okay? -infinity to -10, union -10 to infinity, okay? So those are some foundational skills that we're gonna need for this unit, okay? We're gonna pick more up with the graphs, all right, in the next lesson.